Welcome, guys. So here is our difficult problem in this exam. I think this problem is very difficult. Suppose f55. Suppose f is twice differentiable, and you know that f of 0, f of prime 0, and f double prime 0 are negative, and f prime has these three properties. You see, a lot of properties. Usually, this is difficult. And what is the same properties f necessarily have? Okay, so you guys already remember the problem, right? So we have negative, also f double prime increase. Second is f double prime has unique 0. The third is f prime double prime is unbounded. Okay, so the difficult part is we need to use all of this information to get the information of f. So basically, in order to get a feeling, we can view f prime like, suppose it basically is negative, but it's unbounded, so it will go to infinity, and then it will only have 1 zeros. So maybe f prime looks like this. This is example. This is just, yeah. Okay, so suppose this point is called C. This point will call C. Oh shit! So you will. Okay, maybe I'll call it C. Okay. Okay, so basically we first need to know the property of f prime. Okay, so I claim what? I claim since we only have f double prime, right? So we need to find f prime. I claim f prime has 2 and third property. This is not easy to see. Okay, but basically we can prove this. Since f prime can be written as so since there's a point C, so I can written this as since we know f double prime is unbounded, so when x goes to infinity, then this term can be arbitrarily large. So basically, this tells you that f prime can be arbitrarily large. So basically, f prime is unbounded. So we have 3. The difficult part is f prime has uniquely 0 at some point. This is difficult. Okay, so let me explain. The problem is that okay, so suppose this is f prime, and we only know it's negative at some point, at 0 point. Okay, and what we want to claim is f prime has uniquely 0. So how do we prove this? Is that we want to show that f prime only has uniquely 0 at in 0 to infinity. So let me ask which point which point is possible. So there are 3 possibilities. So one possibility is that f prime has zeros when x is larger than C, or f prime has zeros when x is less or equal to C. Right? You have two kind of properties, 2 kind of possibilities. Okay, so I claim this one is correct. The reason is that f prime of C minus f prime of 0 will equal to f double prime for some e dot points C, and this is negative. and this double prime from between 0 and c, then this is negative. So basically this tells that this term is negative and this term is negative, so f prime of c must be negative. So at this point f prime of c must be negative, and the f prime of c also needs to be smaller than f prime of 0. So this is the possible shape. This is the possible shape of f prime. It need to be decreased, and it need to be negative. Then after that, the f prime start to increase. So it start to increase. Since f prime is starting to increase, so there's only one possible zeros here. There's no way that you have 2, because if you have 2, then f prime will decrease. F double prime will decrease. So we show that the second is correct. So once we know that, then we can solve our problems. It looks like we did something which is irrelevant. Okay. So the first one said that f is increasing. The second one said that f has unique 0, and the third said that f is unbounded. Okay, so remember that we have this diagram. So now f prime's shape looks like it decreased at some point and then start to increase at some point. I call it E. Okay, this is f. So f is also 0 at some negative point. Okay, so the first thing is f is unbounded, and the reason is the same as before, since that we know that f prime can be arbitrarily large, so f can be arbitrarily large, so f is unbounded. So the third is correct. And the second, f has uniquely 0. This is also correct. And the reason is that what we want to ask is, which points can be 0. So basically when you see before E, the f prime is negative before E, the f prime. So basically if you from 0, then before E it should start increasing, and at point E then it start to increase forever, right? So it start to increase. So from the plot so the same strategy proves that it has only 1 0 here. So the second is correct. Then the first one is wrong, right? So basically f is not decreasing from 0 to infinity. F start decreasing, and after some points it start to increase. Yeah, so this problem is difficult. You need to think carefully. Basically the proof first use so basically once you know how to prove the property of f prime, then you can prove the property of f. And the proof is just using the mean value theorem and some common sense. But I think the logic is somewhat complicated. So this is the 55. And be sure to subscribe to my channel. Thanks.